This is another question on the differentiation using the first principle. Don't forget that I told you in the previous video that we are actually finding what? The slope of a curve. Now, this is a complete curve. This is a complete curve. This is one of the simplest curve. The one of the simplest curve we have is what? Is the quadratic function. We still have the polynomial x raised to power 3, x raised to power 4, x raised to power 5, x raised to power 6. They are polynomial. They are what? They are greater than this what? Quadratic what? Function. But a quadratic function is also a what? It's also a curve. So how do we get the slope of this? Now the slope of the normally, if that's to find the slope of this, we can solve it using a graph. But in this case, we don't want to draw a graph, we don't want to draw a curve. We want to find the slope. And if I decided to find the slope, I can, under this part rather too, I'm only finding the function that will lead to the slope. The function, after I've solved it, the answer I'm having is that function that will lead to the slope, depending on the what? On the points given to me in the question. So after I've gotten that what? The value or the functions, I've resolved the function to the something that can lead to the what? To the slope of the function, to the slope. All I need to do is what? Is to input the value of x inside it to get my slope. That means what I was trying to tell you in the what? In the previous video, that the slope of a curve at every point are different. So if I have arrived to what? To a function that can lead to the slope, then I can now what? Find the slope at what? At any point I am what? I am giving. So here now, since I'm giving y equals to x squared plus 4x minus 5. So how do I find the slope? Don't forget that the slope that I'm looking for here, all I need to do, the first thing is what? Is to add what? The difference in y here and difference in x, the difference in x. So whenever I see y, I'm going to add the difference in y. Whenever I see x, I'm going to add the difference in what? In x. So therefore, y plus dy equals to x plus dx. I'm having power of 2 here. 4 also x plus dx minus 5. So let me open this bracket. So y plus dy is equals to x plus dx, x plus dx, because I'm having 2 of this here. This power of 2, that is 2, plus 4 bracket x plus dx minus 5. So y plus dy equals x times x is x squared, x times dx is x dx. This one is what? X dx. This one is what? Dx squared plus 4x plus 4 dx minus 5. I use this to open this bracket. So these are the same thing. So y plus dy, I'm going to have x squared. Add this together, I'm going to have 2x dx plus dx all squared plus 4x. So this should be 4 dx. 4 times dx, that is 4 dx minus 5. So 4 dx minus 5. So what do I do next? Now I have to bring this y to the other side. Now bring the y to the other side. I'm going to have what? Dy equals to x squared plus 2x dx plus dx all squared plus 4x plus 4 dx minus 5 minus y. So what is my y? My y is x squared plus 4x minus 5. So dy equals to x squared plus 2x dx plus dx all squared plus 4x plus 4 dx minus 5 minus open bracket. What's my y? My y is now what? X squared plus 4x minus 5. So this minus is going to affect everything inside this bracket here. So the y will now give me x squared plus 2x dx plus dx all squared plus 4x plus 4 dx minus 5 minus x squared minus 4x plus 5. So what next? This one we cancel this. This 5 we cancel this. This 4x we cancel this. So I'm left with dy equals to 2x dx plus dx squared plus 4dx. So I'm going to divide through by dx. Divide through by dx. Dx. Dx we cancel dx. Dx we cancel. I'm left with 1 dx here. Dx we cancel dx here. So I'm left with dy over dx equals to 2x plus dx. I'm left with 1 here plus 4. So what do I do next? Now I'm going to limit the x tends to 0. So limit limit dx to what? 0. I believe you can see it from here. Can you see it from here? Okay, you can't see it. So let me write it on this paper. Limit ds to 0. So I want to limit ds to 0 here. So what do I do? So how do I limit ds to 0 here? Very simple. Now to limit ds tends to 0, whenever I see ds, I'm going to put what? 0. So dy over ds equals to 2x plus, this one has become 0 plus 4. So dy over ds equals to 2x plus 4. So this is also a function. It's a function that will lead to my slope depending on the points I am given. So you can see that I've resolved this function and use it to this function. So all I need to do here is that I'll be given a point that maybe x is 3, x is 2, x is 1. I find the slope. So if x is 3, if I put 3 here, that is 3 times 2, 6. 6 plus 4 is what? 10. That means my slope at point x equals to 3 is 10. If my point is 2 also, that will be 2 times 2, 4. 4 plus 4 is 8. So at point s equals to 2, my slope is equals to 8. So the job of this differentiation is to resolve that function to a simpler function that will give you the slope. Then input the value of your what? Of your point as x inside to find the slope of that point. So that is it. So my next video, I'm going to what? Solve more question on what? Differential calculus, another method. This is what? This is first principle. This is first principle. We still have what? The general rule. We have the chain rule. We have the product rule. We have the quotient rule. We still have the trigonometry what? Aspects. And we still have what? The implicit. So in my next video, I'm going to what? Do them gradually by gradually. Then what? We finish